Hello, my name is Scott Cheatham, and I'm with the Richmond Hospital Education Program. And today we're going to be doing a second lesson that I've created on the process of completing the square. This lesson is going to detail what to do when the leading coefficient is a number other than 1. And so for those of you that are familiar with what the term completing the square refers to, that idea of the coefficient being 1 hopefully makes sense. But this is a process by which we can rewrite certain quadratic equations in a way that's going to be helpful to us, either for solving or for graphing purposes. And this technique is something that gets referenced in Algebra 2, but can also be used further on in trigonometry classes or in calculus classes. If you're familiar somewhat with the process of completing the square, this could be a helpful video for you to look at without having watched my other presentation on this. But this also might be helpful for you to look at the process when you are doing this with a coefficient of 1 before you come to this video. Today there are going to be some times where I recommend that you pause the presentation and work out some problems and then come back to it. You're not going to really need anything other than just some paper to take notes and work out some problems and a pencil. If you want to use a calculator, you're welcome to do so. You could use the Desmos calculator in order to do some basic calculations, but we aren't going to need to do anything really that's going to require us to be using a graphing calculator. So as a warm-up here, I've got the rule here of the quantity of a plus b squared equals a squared plus 2ab plus b squared. This sometimes gets referred to as the perfect square trinomial rule. And so basically what that means is if you have a binomial squared, it's important that you don't just square the first and the second term. That's not how squaring works. But what you can think of it as, okay, well, I'm going to have that first term squared and my last term squared. But if you think of it in terms of foiling, or if you were expanding that binomial, you're going to double a and b multiplied together. And so rather than writing this as a plus b times a plus b and doing the whole foiling process, if we can recognize this rule and get comfortable with it, one, it can save us some time, but then two, it's also the foundation of this idea that we're going to be looking at of completing the square. So I want you to try using this rule, working both either expanding or rewriting, going from either left to right for expanding or starting from the right and moving back to the left for rewriting it. So I want you to give these 4 problems a try. Go ahead and pause the presentation and then come back and we'll talk about the answers. And so again, we don't want to think of this as writing it out as x plus 4 is x plus 4 and multiplying that out to 4 terms and combining our like terms. You could do that, but we want to use this rule here. So if I've got x plus 4 in a binomial and we're squaring it, I'm going to take, okay, I've got my first term squared, that's x squared. I'm going to multiply 2 times the first term times the second term. So 2 times x times 4. I would write that as 8x. And then I would take my second term, 4, and square that and get 16. So I want to kind of work through it in that mentality. So for the second one there, I've got 2x minus 3 in a binomial squared. So I'm going to square 2x. You want to be mindful here that if you have a term that is 2x or anything other than just a regular x, you want to square that. And so you want to square both the coefficient and the variable. And so that's why I have 4x squared there. When I multiply those by 2, I need to multiply 2 times 2x, and then I also need to multiply by negative 3. So when I'm multiplying those across, I don't want to forget that negative there, and that's where the negative 12x comes. And then when I'm squaring that negative 3, I've got negative 3 squared, which, again, you're going to have a negative times a negative, which is going to make a positive to give me my 4x squared minus 12x plus 9. Now for rewriting, for going backwards, you can also think of this as factoring. And so there's a variety of different ways you can approach factoring a quadratic. When the coefficient is 1, you can think of it as, okay, what two numbers multiply to get the third that add to get the second? What two numbers multiply to get positive 36 that add to get negative 12? Well, that's going to be negative 6 and negative 6. And that's why you can write it as x minus 6 as a binomial squared. But we don't want to approach it that way. We want to recognize the fact that I've got this perfect square trinomial. It's where the first term is a term that's squared, the last term is a term that's squared, and if you multiply both of those by 2, you get the middle term. So I see, okay, I've got x squared and 36. Those are both perfect squares, and so the square roots of those are x and 6. If I multiply 2 times x times 6, I get 12, which is my middle term. The fact that it's a minus 12x just means that in my binomial I'm going to use minus 6 instead of plus 6. And so that's just that's the way we want to recognize when we look at this. Now it's a little different when you've got the term in front of the x squared, a coefficient other than 1. As far as factoring goes, that would be a different process. But here I've still got a perfect square of 25x squared. I can take the perfect square approach to that because that's 5x squared. And then 1 is 1 squared. And if I multiply 2 times 5x times 1, I get 10x, which is my middle term. So this works as a binomial that can be squared. Now for the process of completing the square, we use the letter C, but basically we're going to expand upon that perfect square trinomial rule and say, okay, well, what would be the value of C that would let us use that rule? So what would be the value of C that would be a number that if we that is squared? The square root of that, if you double it and multiply by the first term, gives you your middle term. And so the way you can also think of this is, okay, if we take the middle term and we divide it by 2, that coefficient, what happens when we square it? That should be our C value. And then whatever that number is that we're squaring, that's going to be, we're going to use that in the square of a binomial. So let's look at, see if you can remember this process. If you've already done my first video, hopefully it should come as a nice review for you. If not, give it a try, and then we'll come back together and we'll talk about what this process and what we're going to be looking for here. So C for the first one is 121. So if I take that middle term, 22, divided by 2, I would get 11x. The square root of x squared is x, so that's where the x part comes from. But so then that 11, that's what I'm going to actually end up using in my square of the binomial. But 11 squared is going to be my C. 11 squared is 121. For the second one there, it's one where I'm going to divide that middle term by 2. I get negative 10. I'm going to square that negative 10. I get my C value, which is 100. But then in the binomial, I'm going to use minus 10 as the term. Now in the third one, it's one where it doesn't work out to where it's a nice integer when we do that dividing. But this process still is going to follow the same rules and still going to hold true. So I'm going to take that 3 and divide it by 2. I'm going to leave it as an improper fraction. I always want to work with that. I don't want to work with decimals or mixed fractions. And then when we square that number for our C, when you have a fraction, you're squaring it, you really just square the numerator and denominator separately. So if I take 3x, if I divide it by 2, I get 3 halves. If I square that, I would end up with 9/4. And then for the value there, you get x plus 3 halves in the binomial, and that's squared. So the last review part here and for this process is when we have a coefficient here that's 1, so it's a 1x squared. and write that quadratic function with the square of a binomial. Well, I'm going to completely discount the 17 for right now, and I'm just going to focus on the x squared plus the 10x. I'm not going to worry about the 17. And so I want to ask myself, okay, what would my value of c be? It's the same process that I just did there. So I'm going to divide that middle term, that 10x, by 2, get 5x. I'm concerned with the coefficient here of 5, and my c value is going to be that 5 squared, which is 25. But I don't have 25, I've got 17. And so I can't just change 17 into 25. But what I want to do is I want to add that c, whatever the c is, to my function here. But I need it to not impact the function. So the way I'm able to do that is I'm going to add c and subtract c on the same side. Some places you'll see it, you'll add c on the right and add c on the left of the equation. Because we're dealing with a function here that we might be graphing, I've just got it all on the same side, and I'm offsetting it by one positive c and one negative c. And again, I said the c value was going to be 25. That 10 divided by 2, that coefficient squared is 25. And so I'm going to add 25 as my c, but I'm going to make sure I don't change the function by subtracting 25 as well. Now, when I look at this, if I just focus on the x squared plus 10x plus 25, I could rewrite that as a binomial that's squared. I've got a positive 10x, so again, I could divide that by 2. That part's going to be x plus 5 as a binomial squared. Now, on the outside, I've got this 17 and this minus 25. Those terms I'm just going to combine together. So my answer here looks like y equals the binomial of x plus 5 squared. 17 minus 25 together gives me minus 8. Now I want you to try this one on your own. This is one where we're actually going to solve. We're going to complete the square and then solve. I want you to see if you how you would approach this. This is one where the coefficient is 1, so we're not to ones yet where the leading coefficient is other than 1. But we do want to go ahead and solve this. So go ahead and give this a try for completing the square and see if you can solve for x. And your work might look a little bit different than mine. You might have an extra step, or you might have skipped a step of my work, and as long as you have the right process down and the inevitable right final answer, that's fine. So my c here, I'm going to take 10x, I'm going to divide that by 2, and I get 5. And so that I've already got the x accounted for because that's the square root of x squared. But so the 10 divided by 2 is 5. I'm going to square that 5 to get my c, which is 25. So I need to add 25 and subtract 25 on the same side. And so when I do that, I get x plus 5 quantity squared minus 28. So that's the process of completing the square. Now, the next steps are ones where I'm going to go ahead and try and isolate x. Now, when I do that, an important thing to remember is that if I am adding a square root to the problem, then I need to add a plus or minus. So right now there is no square root in the problem. It doesn't already have one. And so if through the process of me trying to isolate x, if I need to use a square root on both sides of an equation, when I do that, I need to add the plus or minus in from there on. And so when I do that here, I moved over the 28. I've got the binomial of x plus 5 squared equals 28. Well, I can get rid of that squared by taking the square root of both sides. But when I do that, I'm going to have x plus 5 equals plus or minus the square root of 28. That plus or minus has to be there. Now 28 is 4 times 7, so I can pull out a 2 there. I'm assuming that you're comfortable reducing square roots, being that you're in Algebra 2. If you need to refresh on that, that might be something you need to do in a different lesson. And then when I isolate x here, I'm going to move over that 5. It's going to be on the left here. I would have negative 5. When you look at this, this might look like an answer that you could get if you use the quadratic formula, which it exactly is that way. If you use the whole quadratic formula up there on x squared plus 10x minus 3, you would get this as an answer. This is just another way of solving for quadratics rather than using the quadratic formula. It also gives us some benefits of seeing something written in vertex form, which we're going to talk about a little bit later. Now, with quadratics, it is not always going to be the case that the leading coefficient is 1. So we're not always going to have a 1x squared. We can have that leading coefficient can be anything. It can be any positive number, any negative number. Really, it could be any rational number, although we're going to primarily just deal with integers here. But we need to understand, okay, what impact does it have if that first term is different than 1? So what we're going to do is we're going to factor that coefficient out, but just from the x squared and the bx part. Whatever that c was, that we're going to leave that out for right now, and I'll kind of explain what that looks like to go from there. And then I say this point here, be careful to account for the factored out coefficient when you offset your value of c, and I'll show you what that means in just a minute. So for here, I've got y equals 2x squared plus 4x minus 4. This is a case where the leading coefficient is not 1. So let's say I wanted to take this and rewrite it in vertex form. I wanted to complete the square to be able to graph this a little bit easier. So I've got all the work here, but I want to walk you through what these steps are and what we did in each spot. So what I said in that first bullet is that you want to factor out whatever that coefficient is just from the x squared and the bx. So if you look at the second line there, factoring out that 2 is what we want to do. But we only want to factor it out from the 2x squared and the 4x term. That minus 4 I'm going to just leave on the outside right now. I've not changed this expression at all, or this equation at all. I've just factored out a 2 from those first two terms. And now I've got x squared plus 2x. So from here, I want to approach that parentheses with the completing the square process that I've already done. So I'm going to take that middle term, 2x, I'm going to divide it by 2, and I'm going to square it. So when I divide it by 2, I get 1. And when I square it, I also get 1. And so my c that I'm going to add to be able to have a binomial that's squared is 1. And so I'm going to leave that there as my third term. Now, the same rule applies that when I offset my value c, I have to completely do that. So rather than just subtracting 1, I have to account for the fact that I have a 2 factored out of the parentheses. So what I've actually added to the equation is that 1 times whatever I factored out, in this case, 1 times 2. So when I offset it, I'm going to subtract the 2 times 1. And that's what you can see there. Rather than just subtracting 1, which is what we have been doing to this part, we subtract the number that's on the outside, 2, times that 1. And then I go ahead and evaluate what's on the outside. Minus 4 minus 2 times 1, so that's minus 4 minus another 2. I get minus 6. And then that 2 stays on the outside of the binomial that's squared. And so we have 2 times the binomial of x plus 1 squared. The big thing that people forget here is they forget to account for that factor that they factored out when they're offsetting the c. They'll just put minus 1 in this case, rather than having the 2 out there as well. So make sure whatever you're factoring out to be able to complete the square, make sure that you completely account for whatever you're adding in to do that by multiplying by that factor out, that number that you factored out. So we have quadratic equations here. They're functions that could be graphed, and we want you to rewrite them using the square of a binomial. This is another way to call this is vertex form. We'll refresh what that means in a minute, but it has some benefits to us to be able to understand where the vertex is and how we can graph these. Also has some benefits in how we can solve them. So again, we're going to factor out whatever we need to, but again, just from those first two terms, and then make sure you offset that C properly. I want you to go ahead and work on these three and go ahead and pause the presentation and then come back and we'll talk about the answers and make sure we all feel comfortable with them. So for this first one here, we have y equals 3x squared minus 12x plus 1. So I'm going to factor out a 3, but just from the 3x squared and the minus 12x. That plus 1 is just going to stay on the outside. And then I'm going to do my completing the square process, but whatever I add in as my c to offset it, I also then need to multiply that by this 3 that I've multiplied, that I factored out. So I have multiplied out the 3. I got x squared minus 4x. And that plus 1 is going to stay on the outside. That minus 4x I divided by 2. And that number, that coefficient, I'm going to square it. That's going to be my c that I use for completing the square. And when I do that, I want to offset by including that 4. And so I'm going to negate it. I'm going to subtract 3 times 4 because I've got that 3 factored out. Because really what I added to the problem was 12. And when I do that, I end up with minus 11. And I've got the 3 times the binomial of x minus 2. Again, I got that minus there because it's minus 4x. And that binomial x minus 2 squared. Now this one does have a coefficient that's not 1 there. It happens to be a negative 1. And so because this is a function that we're graphing, I can't just multiply through by negative 1 and get rid of it. If it was like, if it equaled 0 and I was solving, I could do some different things to it to just kind of negate some of these negatives, or I could divide out some of these terms. But I can't do that here, so I need to go ahead and approach it where I'm going to factor out that negative 1. But again, only from the negative x squared and the 14x. So when I factor out that negative, it changes the signs there. But negative 14 divided by 2. And then square that number, I get positive 49. But really what I did here is I added in a positive 49, but multiply by negative 1. So to negate it, I'm actually going to add 49 in there. You might have written minus negative 49, and that's fine. I went ahead and combined those two negatives into a positive. And then you get the y equals negative, the binomial x minus 7 squared plus 4. Now this one here, I'll just go ahead and say it did have some fractions in it. And so when you're doing this one, if you got fractions, you're on the right track. Because I do need to factor out that negative 2x. And that ended up causing me to have some fractions that I was going to be using when I was doing the completing the square process. So I've got negative 2 factored out. That means that what I'm going to be trying to complete the square with is x squared plus x. That minus 7 I don't touch. That just stays outside as minus 7. Now I've got 1x, so I'm going to divide that by 2, get 1/2. And to get my c value I'm adding, I'm going to square it. So when I do that, I end up with 1/2 squared, which is 1/4. Now I've added 1/4 into the problem, but I've added 1/4 times negative 2. So I need to negate that. So here you can see I do have the double negatives just to kind of illustrate that. So negative 2 times 1/4, but I'm subtracting that from 7. If it's helpful for you to go ahead and think of 7 as 14 halves or negative 14 halves, you can do that. And you're subtracting or you're in effect adding 1/2 to negative 14 halves. That's where the negative 13 over 2 comes in. So I've got negative 2 times the binomial of x plus 1/2 squared minus 13 halves. All right, now for this one here, I want to go ahead and solve it. Now I want you to solve this using the completing the square process that we've been doing, but I'm going to explain one kind of shortcut that you could have used after you do it, and you might see it, and if you do, good for you. But go ahead and how would you solve this one? Note that you may have complex answers, so this is one where we're going to solve it where complex numbers are allowed. Using that square root method where if you add a square root, then you're going to have a plus or minus in your answer. So go ahead and give this one a try. Okay, so we've got 3x squared minus 6x plus 12 equals 0. Anytime you're solving a quadratic, you want to get everything on one side and get it equal to 0. Now I had 3x squared, so I need to factor out that 3. But again, only from the 3x squared and the minus 6x. And so when I do that, I get x squared minus 2x, and that 12 just stays on the outside. Well, negative 2 divided by 2 is negative 1. When I square that to figure out what my c value is, I'm going to include in there, I get 1. But really what I've done to this problem is that I have added in 3 times that 1, so I need to subtract by 3. So you end up getting 3 times the binomial x minus 1 squared plus 9 equals 0. And from here to solve, I'm going to move over the 9 and divide by that 3 to where I can get that x minus 1 as a binomial squared by itself. I do need to add a square root to this problem, and so when I do that, I end up with needing to add a plus or minus. I also end up taking the square root of a negative number, and that is allowed when we're allowing complex numbers, and so we end up with I times the square root of 3. I move that 1 over, and you get 1 plus or minus I times the square root of 3. That's the same answer you would have gotten if you had used the quadratic formula on the first original problem. Now there is one tip that I wanted to give you. So if you look up there, that 3x squared minus 6x plus 12, you might notice that there's a common factor with all 3 of them. And here, because it equals 0, there's actually something we could have done. So when solving, you can actually divide out and reduce by a common factor at the beginning to give yourself smaller numbers. So for that one there, you had 3x squared minus 6x plus 12 equals 0. If I divide both sides by 3, that gets me down to x squared minus 2x plus 4. And because it's equaling 0, and 0 divided by 3 is still going to be 0, I'm allowed to do it. If I'm trying to write an equation or a function where it's y equals something, I can't just divide both sides by a number. But in that case where I'm solving, I am allowed to do that. All right, the last ones we're going to look at is vertex form, and this might be one where if you want to plug it into your Desmos graphing calculator, you can. It's called vertex form because this process of completing the square actually gives us a binomial squared where it's in vertex form where the vertex is given to us. So the vertex, the coordinates h and k are typically what's used. The vertex, it ends up being minus or opposite of whatever's inside the parentheses. And then k is on the outside. That's the vertical shift, and that's whatever that value is. And so this gives us where the vertex is. The a value tells us if the quadratic equation is going to open up or if it's going to open down, and how steep or wide the opening is going to be. But so if you can complete the square, again here we're not solving, so we can't be dividing things out or do anything like that. But if we can complete the square of each side, then we can say, okay, well here's the vertex. So go ahead and try it for these last 3 here. And then we'll come back together and make sure we feel comfortable saying what the vertex would be. So the first step there, because this is one where I don't have to factor out anything because it's a coefficient of 1. So I'm going to figure out what's my c, and I'm going to offset it. So I've got negative 8x. I divide that by 2. Get negative 4x. That negative 4, if I square it, that's going to be my c value for completing the square. And so I'm going to add 16. But I need to offset that 16 by subtracting by it. So when I do that, I do need to have that minus 16 on the outside. And again, I'm going to have minus 4 because it was negative 8x. I'm dividing that by 2 and get that negative 4 there as the second term in the binomial. And on the outside, when I combine those like terms, I get minus 5. The vertex there is it's the opposite of whatever's inside the parentheses, so it'd be positive 4, negative 5, so that'd be a quadratic function opening up. It'd be like if you shifted over the parent graph from the origin over 4 and down 5, and that's its vertex from this vertex form. Now for this one here, we had a number in front of the x squared, so the leading coefficient was not 1. So I do need to factor that out. But again, I'm not going to factor it out of the 7. I'm just going to factor it out of the 2x and the 4x. And so whatever I add into that c, I'm going to offset by multiplying it by that 2 times the c. And so what I'm adding in, I'm going to take that middle 2x divided by 2, and I get just 1x. So that 1 squared is 1. And 2 times 1 there. I'm going to offset. I'm going to subtract by 2 times 1. So I get minus 9 on the outside. The vertex there, again, opposite of whatever's inside those parentheses for the x value. So negative 1. The outside number is negative 9. The 2 doesn't actually impact the vertex. The 2 impacts how steep it is. If it's a number with an absolute value greater than 1, then it's going to be more steep than the parent graph. If it's between 1 and negative 1, then it's going to be kind of wider. And again, if it's a negative number, then it's going to open down. Last one here, we had a negative 3x squared that we're going to factor out. But again, only of the negative 3x squared and the 6x. We're not going to take anything out of the minus 8. And so when you do that, you end up with that minus 2x there that we're dividing by 2 and squaring to get our c, which is just 1. But we do need to offset that by multiplying by negative 3. So we got some double negatives here. So what we're actually offsetting it by is by adding 3 to that negative 8. Turns that outside value to negative 5. The vertex, again, is that opposite of that negative 1. So it'd be positive 1, negative 5. That negative 3 doesn't impact the vertex. It does mean, though, that the parent graph would be opening downwards and a little and more steep than a typical quadratic parent graph. I hope this lesson has been helpful for you. Again, this process is one that you start to use late in Algebra 2, but in trigonometry and beyond in calculus, it's helpful to be able to do this for a variety of graphing and solving purposes. If you would like some more practice, the Richmond Hospital Education Program has a subscription to IXL, as do many school districts. And then under the Algebra 2 modules, under K, 9, and 10, there's some more practice on completing the square and solving quadratics using completing the square. But again, I thank you for listening, and I wish you well with the rest of your school year. Thank you.